Sketch the graph of f of x is equal to x divided by x squared plus 1. Or when we are sketching rational graphs, one thing we want to find is the asymptotes, the intercepts, and also the turning point. So let's look at the asymptotes. So we see if we want to get a vertical asymptote, that is the x value for which the function is undefined, we equate the denominator to 0. X squared plus 1 is equal to 0, and that will give us x squared being equal to negative 1. So to find the value for x, we take the square root of negative 1. We don't have the square root of a negative number. So that means we don't have any vertical asymptote. So no vertical asymptote. In other words, the graph is true for all values of x. Now, another thing is to consider the horizontal asymptote. For the horizontal asymptote, you take the limit as x approaches very big numbers, either positive or negative infinity, of this function x divided by x squared plus 1. So this one, what to do is, we'll look at what we have in the denominator. The highest power of x is x squared. So divide everything by x squared. So that will be the limit as x approaches positive or negative infinity of x divided by x squared. That is going to be 1 over x. And then x squared over x squared, that will be a 1. And then plus 1 over x squared. And now we can replace where there is x, we put infinity. So that will be 1 over infinity divided by 1 plus 1 over infinity squared. Infinity is a very big number, and 1 over a very big number, actually just any number over a very big number, it goes towards 0. And then even here, when you square a very big number, it still be a very big number, and 1 over a very big number still be 0. So we've got 1 plus 0, and 0 over 1 plus 0 is a 1, 0 over 1 is a 0. So this will be the y value as we approach infinity, it will be 0. Another thing that we need to find is the turning point. And for the turning point, we use the derivative. So f prime of x is going to be equal to, we get what is in the denominator, that is v, and then we say du over dx. U is what is on top, and then minus the same u what is on top, then dv over dx divided by v squared. So that is going to give us v, what is down is x squared plus 1. And then we differentiate what is on top, that is du over dx. If we differentiate x, we'll get a 1. And then minus what is on top, that is x. We differentiate what is down, we're going to get 2x. And then divide by the same thing which is down, but square it, that is x squared plus 1 squared. But we want the turning point. Another turning point, when something is turning, the gradient is equal to 0. So f prime of x is going to be equal to 0. This is called the gradient function. So if we multiply this by that, because this is 0 is the same as 0 over 1, and then multiply this by that, we are going to just have 0 being equal to 1 multiplied by this will just be x squared plus 1, and then minus 2x squared. X squared minus 2x squared, that will be negative x squared. So 0 is equal to 1 minus x squared. You can take x squared this side. That is going to give us x squared being equal to 1. Well, what will be the value for x? If we square root, that will mean x is equal to 1 or x is equal to negative 1. Well, when x is 1, what will be the value for y? We go in the original function. Y is going to be, we put a 1 there, we put a 1 there, we put, this is already a 1. So that will be 1 divided by 1 squared plus 1, which is simply 1 over 2. So we are saying the turning point, the first value we have is 1 comma 1 over 2. And then we also have x to be negative 1. So put a negative 1 here, but we are squaring that, and then also on top a negative 1 when x is negative 1. So when x is negative 1, y is going to be what? Negative 1 squared is still a 1. and 1 plus 1 is still a 2 in the denominator. It's just that on top we have got a negative, so that is going to be negative 1 over 2. So those are the turning points. We can now go on and see the sketch of this diagram. We have got x there, we have got y there, and so the turning point, let's say this is a positive 1, this is a half, this is a negative half, and then this is a 1. So the turning point, we have got 1 comma 1 over 2 and negative 1 comma negative 1 over 2. So this is where the graphs are going to be turning. And you know that the graph, well, another thing we could have found is the x and y intercept. X intercept, let me first find the y intercept. Y intercept happens when what? X is equal to 0. X is equal to 0. So where there is x, we put 0, 0 there, 0 there. So it will be 0 over 1, which is simply a 0. So the intercept, it is at 0, 0. So the graph is going to cut at 0, 0. So this graph is, as we go towards infinity, whether negative or positive infinity, we see that y is approaching 0. So as we are going towards very big numbers, very small values of x, it is approaching 0. And then as we go like this, it's going to come and have a turning point at this point, and then it's going to go back and pass on the middle, and then here it was also having another turning point, and then it continues to go like that. As we go to very big values of x, the function will also be approaching 0 again, just like for small values of x. Okay, like that.